cool. Hello, everyone. Really glad to be here. I'm Kang. I'm from Instagram called Client Team. Our team just moved from Bay Area to NYC early this year, and we are located in the Cooper Square in our own office. So today I'm going to talk about how our Android apps architecture evolved in these years to support our product need while achieve performance and reliability goals. So as a too long didn't listen version, we'll start from discussing the challenges that's unique to mobile development and some best practices we summarized over these years to tackle those issues. And we will want to share some stories about how we apply those best practices in our day-to-day development, and hopefully that could be useful to someone here. So first of all, I forgot to introduce the company itself. So Instagram is a social mobile app for people who, for anyone who doesn't know what Instagram does. Android is growing really rapidly in recent years. So I think in last year, there are more than 1 billion mobile devices got shipped, and more than 80% of them are Android devices. So the market is huge, and there are a lot of opportunities. But Android has, while the market is very big, there is this fragmentation problem. Right now, there are more than 7 different OS versions on the market. There are 6 different DPIs. Android can run on your phone, on your TV, on your watch. There is even new laptop comes with Android. So as a developer, we have to factor all those in when we do mobile development and take all those into consideration. Another big difference in, another big challenge in mobile development is the really fast release cycle. So unlike desktop software, which usually takes 6 months to a year to do update, mobile apps tend to upgrade much more frequently. For instance, at Instagram, we update the app every 2 weeks. That means you have very little headroom to do big planning for your architecture changes. So you have to, there are a lot of moving pieces that you have to plan carefully. Instagram for Android app was released in 2012, early 2012, and ever since then, we got more than 500 million downloads in Play Store, and we maintained 4.5 star ratings. Personally, I feel it has a lot to do with how we do day-to-day development, and I'd like to share some values we summarized in these years. The first thing is about simplicity. So Instagram as a product itself values simplicity a lot. The product doesn't have that many features, but every feature is well polished. On engineering side, we value simplicity as well. So whenever we get a hard problem, we try to divide it into small pieces and see what's the most important part. Try to minimize the goal and try to work on the most important part first. That really helps because in very fast release cycles, you really want to avoid over-engineering stuff. The second part is about performance. Every time when we finish a new feature, a new product, we would test it on real devices and see how it performs there. And just like any performance issues in computer science, when we talk about performance, we talk about the worst case scenario. So we would test our app on a phone with the slowest CPU, with the oldest OS version, and try to make sure that app flies there. And that guarantees we can have a good performance even if the market is so fragmented. The third part is about the code base itself. We try really hard to make sure the code base is consistent, is coherent. If there is any, there should always be one way and only one way to solve a certain problem. If there are more than one solutions to a particular problem, there needs to be a clear guidance about when and why you should prefer one over another. So we don't have legacy code in our, we try to minimize the legacy code in our code base. We do clean up periodically. That's some of our best practices. And the first story I would like to share is about our JSON parsing logic. So when The first two engineers, Philip and Shen, started working on the Android app in 2011. One of the earliest technical decisions they have to make is about how do we parse the data we get from server. So as we said, do simple thing first. So they Google searched a little bit, found this best JSON parser for Java, which was Jackson back to that time. They just used it in our app. They imported the library, finished all the features, and started profiling the app on low-end devices. And it turns out on a low-end Froyo device, probably a lot of people here don't even have a Froyo device anymore, but on a low-end Froyo device, it could take up to 20 seconds to just parse the response, the JSON payload for our Explore page. Explore page is the second tab in our app. So why is JSON parsing so slow? In order to understand that problem, we have to look at how JSON parsing works. Most of those modern JSON parser parse the JSONs in two passes. In first pass, it will pass the JSON token stream into nested key value dictionaries. And in the second pass, it will pass this nested dictionary into the actual model class you use. There are two problems here, two problems on Android here. So the first problem is that because it needs to allocate this intermediate nested hash table / dictionary, it causes a lot of allocations, a lot of short-lived objects in your heap. So it puts a big pressure to Dalvik's garbage collector. And because Dalvik's garbage collector is not that good, especially in the old days, it's not even concurrent, so it slows everything down, and because of the allocations. The second problem is that in order to map the nested dictionary into the final model class, most of those JSON parsing framework use reflections to figure out where this field should be mapped to. For instance, for this name field, it will look up in your model class to look up all those JSON annotations and see which value this name should be mapped to. So in order to solve this issue, what do we have to do? What we have to do is to use streaming parsing. So what we want to do is, instead of generating this intermediate data structure, we parse the JSON token stream into model class directly, bypass the intermediate objects. And in order to solve the reflection cost, we use string comparisons. We hard-code all the strings. We map name to name field on the model class. That makes everything much faster. But back to that time, there was no JSON parsing framework could do this. So what we ended up doing is we just hand-coded a lot of JSON parser. This might sound crazy, but if you think about it, there are not that many payloads in your app actually are that big, and it needs to be optimized. Second of all, this kind of parsing logic is very easy to be unit tested. So we converted most big endpoints in our app to use this technique and leave those small ones to still use object mapper. Again, optimize what matters. Don't do premature optimizations. So fast forward a few years, after we have more and more people joining our team, we committed more and more code. The team size grows, the product gets more and more complex, and we have more and more JSON, hand-coded JSON parser in our code base. As I said, it's very easy to unit test the JSON parser, but still, like time to time, bug will slip into it. And we reached a point that we have so many JSON parsers, every release we would have a hotfix for some of them. So it's time to revisit our approach. So what we did is we created this tool called IGJSON parser. It's, by the way, it's open sourced on GitHub already. So what it does is it's an annotation processor. So it will scan through all your model classes and analyze it and try to generate the efficient streaming parsing code for your model class. So after we have this annotation processor, we got the very flexible framework, and we got the very good performance. So this is basically a story how we do engineering at Instagram. So we first do simple thing first, just pick up whatever we have, whatever is available on the market, and use it and fine-tune the performance, and then later try to improve the workflow whenever you hit new issues. In 2015, we successfully removed object mapper entirely from our code base, and our code base only use the new JSON parser we wrote. The second story I want to share is about our media rendering logic. So a core part of Instagram's experience is about users' photos and videos. So if you look at the app, I have 3 screenshots from the app. They all from different features, but they all render the media in the exact same way. So it makes sense to use the same code in all these 3 places. So how would you reuse it? Luckily, Android has a well-known pattern called a view binder. Basically, for every item view in your list view, in your adapter, you create a separate binder for it. Therefore, you can reuse this binder across different screens and reuse it to get more code reusage. So as you can see here, we have the entire screen is one media view, so we have one view binder for it, and we reuse it in different screens. So we heavily applied this pattern to our code base. We used it, again, do simulation first. We were pretty happy with the result. But while the product gets more and more complex, we start feeling more restricted by this pattern as well. So the biggest problem we hit was performance issue. So if you think about it, when the product gets more and more complex, you will have each item view in your list will get more and more complex. Therefore, they could also get bigger and bigger as well. For instance, for the example I show here, our media view is even longer than a full screen. So in order to get best scrolling performance, we all know that those phones render 60 frames per second. You have to finish all the work in 16 milliseconds. To lay out a whole large view like this, to lay out and measure and render it takes a long time. So you could easily take up to like 20 to 30 milliseconds. And the user will start seeing frame drops. So the solution to that is that you want to divide your big views into smaller item views, so that instead of rendering the whole media using one item view, you render it with 3 item views. But this is what's called multi-row rendering. So the problem with this approach is that if you do multi-row rendering, you will map one model class into multiple views, means you will map them to multiple view binders. Now it's going to be really hard to reuse your rendering logic across different screens because you have to reuse 3 or 4 different view binders together. Another hard part is that because you now break the assumption about one-to-one mapping between your model class and the item view, it's going to be really hard to manage this mapping at data level, and you have to do some crazy math, especially when you have multiple types of model classes and you map them all into you map them all into multiple views. The math gets really complicated there. So in order to solve this problem, we spent some time to create our own solution, which is called binder group. Binder group, as its name, it's an abstraction. It's an abstraction layer between adapter and the binder. It allows you to group a few binders together and use them as one unit. That solves the problem that you can still divide one model class into several views, but you can easily reuse this real logic across different adapters. So as the example I show here, the entire screen actually is divided into 4 item views, but it's grouped into 2 binder group, and you can reuse the binder group as a whole unit. Another thing I want to call here is that the binder group API itself manages the internal mapping between the position and the actual view. So you no longer have to do the crazy math to figure out for position 100, what view should I display. One last thing we spent a lot of time to do here was to make sure our API integrates with adapter API seamlessly. That means our API look very similar to adapter API, so everyone who is familiar with adapter can easily pick it up and start writing this new with this new infrastructure. That's also related to our best practice, do simple thing first, which we spend a lot of time just to make sure this API provide a very smooth upgrade path to see very simple use case to very complex and performance use case. And yeah, that's basically what I want to share today. I hope I have one more slide, but well, we are hiring as well.
Hi, I wanted to ask if Binder Group is also open source, or if you have any plans to make it that way.
Yeah, it's a very good question. It's not open source yet. I wish we could open source the entire Instagram Android source code. It's really clean. It's really nice. It's startling close to the vanilla Android code base. We don't have anything fancy. But right now, for Binder Group itself, we are planning to open source it, but we're short-staffed, so we are hiring. We hope we can hire someone to open source it.
And what's the best way to email you?
Sorry, I should have my...
What's your email address?
Yeah, it's Kang at Instagram. Let me put it here.
What tools are you using to profile your UI?
Sorry.
What tools are you using to profile your UI?
We use different sets of tools. There are internal tools Facebook made to, for instance, to track all the allocations happen during certain period. We also use system trees to figure out what kind of using system trees you can figure out why the frame got delayed, why the vsync is not in sync. But also sometimes you have to use timer and also the sampling-based profiler, which is available, I think, on Lollipop and above. We use all sorts of tools to figure this out. But again, you want to first identify the bottleneck in your current app and tackle that. Yeah.
All right.
Cool.